ending, I-T-E, the root of this bad boy is still the same thing. So, in the event that you have an I-T-E ending, it's the same thing. You take the roots and you put it right here. Now, it should be getting so pumped up that we just finished another one, and we have our third template. Congratulations. TE ending, so this is sulfate right here. This is referred to as the reference anion. Anion meaning negatively charged oxygens compared to the 4 in our reference anion.
Oh, if only he would just talk about stoichiometry.
Okay, let's do this one example. I've picked an example that is not on the super easy side, but not on the super difficult side, but it is a little complex. So you might need to watch this again, but at the same time, stoichiometry in this manner is a whole bunch of unit conversion. It is simple mathematics. You need to write down the units. I'll just say that a billion times. I've written down a bunch of things that we need. Here's our question. We have a solid chunk of aluminum reacting with copper 2 sulfate in an aqueous solution. It is going to produce solid copper. This is a single replacement reaction, if you've noticed already, and aluminum sulfate, aqueous. Now, I've gone and balanced this equation. Remember, if there's nothing there, that means there's 1. This is a really important box to remember. This is called your molar ratio. This means that for every 2 moles of aluminum, it's going to produce 3 moles of copper. Or every 2 moles of aluminum, that's going to produce 1 mole of aluminum sulfate. And I can keep going. It doesn't matter. 3 moles of this makes 3 moles of that, and 1 mole of that. This is a fixed molar ratio. The other thing that we'll need is this formula. The moles equals mass divided by molar mass, and you should know how to do that. We're going to need that. Our question goes as follows, and I've simplified it. If I have 30 grams of aluminum, then how many grams of aluminum sulfate will that produce? So we start with the unit conversion. Here I have 30 grams of aluminum. All right, now I'm going to write my units and what element or compound that pertains to every single time. And I need to convert this. Do you remember the conversion process? Well, I'm going to be multiplying it by this ratio. In this case, according to this formula, mass divided by molar mass. Now the molar mass is, I need to convert this to moles. So grams of aluminum, if you look on your periodic table, 26.98 grams of aluminum for every 1 mole of aluminum. So that, in and of itself, you can see that I'm going to be canceling out grams of aluminum, and I'll be left with 1 mole of aluminum. So this is just a unit conversion. I'm converting 30 grams to however many moles. But I need to convert grams of aluminum to grams of aluminum sulfate. We do that by using a molar ratio. Check this out. I'm going to multiply it by this molar ratio because I know that I need 2 moles of aluminum, because I'm going to cancel out moles of aluminum. 2 moles of aluminum will produce 1 mole. So I look at what the question is asking. I'm looking for grams of this. So 2 moles of aluminum will produce 1 mole of aluminum sulfate. And what will that do? Check this out. Because moles of aluminum will be canceled out by moles of aluminum, and we will be left with moles of aluminum sulfate. So really, it's another unit conversion. So just from here, and let's keep going. We got 30 grams of aluminum, and I've converted it into moles of aluminum sulfate. But we're not done. The question is asking for grams. So guess what? 1 more unit conversion means multiply it by 1 more ratio. It's unit conversions. We need to cancel out 1 mole of aluminum sulfate. But this is the molar mass. We're back up to here. So we need how many? This is the molar mass. How many grams of aluminum sulfate for every 1 mole? Well, take a look at your periodic table, add up everything that you've got, all the molar masses of all the components. You'll find that your answer matches mine, which is 310 342.17. At this point, I would strongly suggest, like, this is a huge number. Double check that. I know you're good at it, but always double check it. So 342.17 grams of aluminum sulfate for every mole. So this is my ratio here. And look what's happening. Moles of this will be canceled out. And we are left with grams, which is exactly what we are looking for. So if you need to roll through all of this math, you can by making this all into a giant formula if you wish. But at the end of the day, our answer is 190 grams of aluminum sulfate is produced. All through stoichiometry, all through unit conversions. See, 30 times 342.17 divided by 26.98 times 2. This is all a big thing. Go review that math. And you can do this with anything. The important steps: balanced equation, molar ratio, unit conversions. Hallelujah. Now, like I said, you can put this all into one big formula. This expanded unit conversion thing, if that's not your cup of tea, put all of this in one fraction that looks like this. So what I've done is I've put 30 grams, all of these fractions, these unit conversions, into one giant ratio. It's same thing. Look, grams of aluminum cancels out grams of aluminum. Moles of aluminum cancel out moles of aluminum. Moles of aluminum sulfate cancels out moles of aluminum sulfate. We're just canceling out units until we are left with what we are looking for, which is grams of aluminum sulfate. And that's that. As we do this, so it's 30 times 1 times 1 times 342.17 divided by 26.98 times 2. Do the math. 10,265.1 grams of aluminum aluminum sulfate divided by the product of 26.98 times 2, which is 53.96. And what does that equal? 190 grams of aluminum sulfate. So it's simple. Do whatever way or method works best for you, whether you have it all in one or just the expanded, or maybe you just take it step by step. It's up to you. But this is how you do it. I hope this helps.